All right, so now that we have this idea of what NumPy is, why we use it, what its advantages are, what arrays are, what multidimensional arrays are, what single-dimensional arrays are, and why these are necessary in data analysis, let's jump into NumPy and begin to sort of understand how it relates to Python. And in order to be able to do that, we have to talk about something called a data type. So up to this point in 101, we've talked about different data types. We just haven't maybe been explicit about it. We have things like strings. We have things like characters. We have things like integers. We have things like float, okay? We've done some different operations on strings. We understand that a string is nothing more than an array of characters, okay? So a character is nothing more than some sort of an ASCII character, right? So I can have a C, or I can have a capital C, I can have an A, or I can have a capital A, I can have the number 3, I can have an exclamation point, okay? And I can put these all in a row, or in a row together, and a collection of characters is what we call a string, okay? So a string would be sort of a type of data type. A character is a data type, but then we also have the integer, an integer being sort of the whole number. There's no decimal in the integer. And then we also have the float, and a float being having a decimal, okay? So these are what we sort of talk about when we mean data type. So in computer science, if someone's saying, well, what kind of data type are you using? Don't get intimidating. They're just asking you, are you using an integer? Are you using a float? Are you using a string? Are you using characters? What are you doing, and how are you representing your data? Okay, so when we're talking about the data types, that's sort of what we're getting at this point. Okay, so again, in Python, we can do some different operations with our data type. We can actually create lists using this package called array. We're not going to mess around with this right now, but it's kind of just demonstrates this idea of a data type. So in general, Python is not what we call a typed language. And what I mean by that is I can create a variable called val1. And in val1, I can put the number 1, and then I can overwrite the number 1 with the letter C, and then I can overwrite the letter C with the name Adam. Okay, what that means is val1 is not a typed variable, meaning a typed variable is I hold only integers, and you can't make me do anything else. Okay, so Python kind of is really flexible. You can sort of do whatever with whatever. But at the same time, when you get down to the lowest levels of computation, you have to have a type. Okay, now again, in the array package, you can actually see that you're actually creating this array of integers where I actually indicates that the contents are integers. Okay, and this actually just creates this array of numbers, and it goes 0 through 9. Boom, you're done. Okay. Now, again, we're not talking about array. Array is kind of interesting, but it's not nearly as powerful as our actual NumPy array. Okay. So in NumPy, let's imagine now we're back in our Python project. We have our import NumPy as NP. Okay. So anytime you see this np.array or whatever, you're just referencing your NumPy package. Okay, so we can see clearly that .array is some sort of a function that NumPy makes available to us. Okay, so we're demonstrating here np.array, and we have 14253, is literally going to just create a NumPy array of 14253. Okay, we can just use the NumPy array to just create arrays from Python lists. Okay, that carries over to if I create a list of words that are from a book. That list has a name, and let's say the list is called words. I can actually do np.array, open close parentheses, and then just put words, the name of the list inside of there as well. And we'll show you that, okay? Now again, when we're talking about NumPy, NumPy is actually constrained to a specific data type, okay? Where Python isn't. I mentioned val1. Val1 can be a number. There could be an integer. Val1 can then be a float. Val1 can then be a string. Val1 then can be a character. NumPy does not work that way, so you have to be very careful. NumPy is constrained to arrays that contain the exact same type. Okay, so in this first example, you can see np.array, 14253, those are all integers, so it comes out with all integers. Well, what happens when we do np.array 3.14 and then 423? We have one float, 3.14. Then we have an integer, and an integer. Well, what we have to look at here is If I convert these to integers, it will simply truncate that 0.14, and I am losing data. Since we're data scientists and doing data analysis, that's not good. But they have to be the same data type. So clearly the only option you have is to convert 4, 2, and 3 into floats. Okay, so here you go. Array, after you run this, it will actually create 4 into a float, 2 and 3 into a float. Now, notice there's nothing here. That just means 4.0, 2.0, and 3.0. Okay? So again, that is how it's going to flex around what you're doing. It's going to try to help you avoid any errors as much as possible. Okay, so you can also, as explained down here below, you can actually do an explicit type. Okay, so let's imagine you want to have a 32-bit float. Okay, so 32 bits meaning you can count up to 4 billion positive, or you can count up to 2 billion positive, you can count down to negative 2 billion positive. It's an unsigned, you can actually count up to 4 billion, and then you can only go down to 0. Okay, that just means the 32 bits just means you can only count up to a certain number. Okay, so here you can actually say NumPy array 1, 2, 3, 4, but you're going to force it to be a float 32-bit float. Okay, so what will end up happening is when you run this, you'll actually end up getting the 1, 2, 3, 4 as floats. Okay, so that's something to keep in mind, that you can't explicitly define what kind of a data type you need to use. Now, if you need to hit pause and think about this idea of data types, think about this idea of having cohesive data types inside NumPy arrays, go ahead and do that. Just understand that you need to have the same data type in your NumPy array. It will not, if you have a list of numbers and words, NumPy array is gonna just convert everything into strings, is what it's gonna do. It'll do it for you, but it'll convert it to strings. Okay, so be careful whenever you're converting your Python lists into NumPy lists, because your NumPy lists are very specific when it comes to data types. Okay, so in this previous slide, we saw that we were sort of creating these hard-coded magic number-ish kind of lists implicitly inside of this np.array call. Okay, I'm just making up numbers, throwing them in there, whatever. Okay, now you can also start, let's say you're going to do some sort of a data analysis, you're using NumPy from scratch, and you just need to create a array of numbers of some sort, just a blank array. Okay, maybe it's an array of zeros, maybe it's an array of ones, maybe it's an array of some specific number. NumPy actually allows you to do some really, really neat things with that. Okay, so the first thing you can do is you can use np.zeros, okay? And essentially what you have here is you're saying, hey, give me 10 of these, and it's going to be of this type. Okay, and you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 zeros, one-dimensional, and they are all integers. Now, if I put float there, it would be 0.0, 0.0, 0.0, 0.0, 0.0, so on and so forth. Okay? All that does is it creates a new array, fills it full of zeros, and gives you this many zeros of this data type. That's all that is. Okay? Now, we also can do a multi-dimensional array. Okay? And the way that we do a multi-dimensional, here you can see you just have 10. Okay, so NumPy is going to go, oh, obviously you just want a list of 10. Okay, so that's a single dimensional array. If you want a multi-dimensional array, you give it how many rows and how many columns. And I'll say that again. Rows, columns, you put it in a tuple and call it a day. Okay, so np.ones will fill it full of ones. You could also do this with np.zeros. And in our exercise in the next video, I'll go through this. I want 3 rows, 5 columns, data type is float. Okay, so 1, 2, 3 rows, 1, 2, 3, 4, 5 columns. 1.0 is a float. They're all floats. So it created ones in the data type of floats, and it filled 3 rows and 5 columns full of that. Okay. Now, you can also do this np.full, which allows you to put your own value in. Okay, so np.full, 3 rows, 5 columns, put 3.14 in. You can see 3 rows, 5 columns, everything is 3.14. You can also do sort of the arrange function, okay, which will go from 0 to 20. This is like range when we do our for loops, right? You start at 0, count up by 2, up to 20, non-inclusive. Okay, so it's literally just like the range function. So I start at 0, here's 0, count up to 20, non-inclusive, count up by 2s. 2, 4, 6, 8, blah, blah, blah. I get to 18. My next addition would be 20, but 20 is non-inclusive, so I don't get the 20 in there. Okay, so that's np.arrange. So if you want to just create a range of counting by tens or counting by hundreds or counting by threes or counting by whatever sort of increment that you want to, you can use the np arrange functionality, which is very, 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 very useful. Okay. We can also do sort of this linear space idea where I can actually create a range of numbers in between two things. Okay, so the lin space idea says I start at 0, I go up to 1, and I go by increments of 0.05. And so you can see I have 0.0, okay, and then I can just sort of jump by multiples of 5 here. Okay, or sorry, not multiples of 5, splitting it into 5 portions. Okay. So I take 0 to 1, it's a range of 1, I divide that into 5, and this is the values that I get, okay? And notice how this one actually is inclusive, okay? Because if it was 5 non-inclusive, then it would have been 0.2, 0.4, 0.8, so on and so forth, but because this one is inclusive, you get 0, 0.25, 0.5, 0.75, and 1. Okay, so that's your linear space. I would definitely explore that. Basically, it'll just crunch the numbers, and it'll fill your space full of linear values between a particular range for you. You don't have to crunch those numbers. Okay, you can also just do a straight up random array. Okay, np random.random. You got 3 rows, 3 columns. Boom, throws it in there. Good to go. Okay, you can also do a normalized random distribution between 0 and 1. Okay, so then I get 3, 3 with a normalized distribution. And then I can also, for those of you who are really into linear algebra, you can actually get your sort of, it's the I, okay, where I get my triangle of linear progression, okay, which is really, really cool. It just gives you a diagonal of 1, okay, so I have 3 rows, 3 columns, and my 3 diagonals, okay. Those are really, really neat. Again, I'm going to show you this in the next video as we sort of work through a lot of these commands, okay. So here are a lot of the standard data types, and I am going to talk you through these. Again, this is 101, so if you don't fully comprehend, it's okay. But essentially, the way that NumPy works is you can have an array. You can have an array of multi-dimensions, and the array must contain one and only one of these data types. Okay, so I can have a multi-dimensional array of integers. I can have, which again, so it's like a C long, so it's going to be like usually a 64-bit integer because you're probably using a 64-bit computer. You can also do an int C, which is going to be a 32-bit integer in general. You can int P, okay, so that's sort of indexing. It's going to be a smaller integer. You can also do 8, which is an 8-bit integer, 16-bit integer, and then you can specify 32-bit or 64-bit integer as well, okay? So those are just integers at different bits, how many bits you have, and obviously if you have fewer bits, you can count up lower, right? So I can't go very far with 8 bits. 16 bits, you'll notice I can go a lot further. 32 bits, I can go way further. Remember earlier how I mentioned with a 32-bit integer, you can count down to negative 2 billion and up to roughly positive 2 billion. Okay, and then obviously with 64, I'm not even going to try to tell you what that number is because it's insanely big. Okay, you can also do this idea of unsigned. As I mentioned earlier, this idea of unsigned means you don't go negative. You can't go negative. Okay, so if you look at this carefully from negative 128 to 127, if you add 128 to 127, you're going to get 255. Okay, so instead of going down halfway and going up halfway, I'm just going to go up all the way. Okay, so my unsigned means I go from 0 to 255. And then obviously these two together is going to give you 65,535. So it goes 0 to 65,535. And then I can count up to 4 billion and I can count up to this big giant number here. Okay. You also have float, and a float is just a 64-bit float, okay, because you're on a 64-bit computer. But you can do 16, 32, and explicitly 64-bit if you want as well. And then you can do complex numbers. Okay. So that's sort of what these data types are and what they mean. Don't be intimidated by it. It's just how many bits do I have and how high up can I count? Does it allow me to have a decimal? Does it not allow me to have a decimal? That's all that's sort of getting at. Okay? All right, so we're going to take a little break. We're going to jump into the next video, and we're going to actually do some coding. So stick around.